Hello student. In this video lecture, I am going to derive the additive property of binomial distribution. The statement of property is: let x follows binomial distribution with parameters n1 and p. Y follows binomial distribution with parameters n2 and p, and x, y are independent. X and y are independent random variables. Then z equal to x plus y. This follows binomial distribution with parameters n1 plus n2 and p. In this statement, we are given two independent binomial random variables with parameters n1 p and n2 p. Then what is distribution of x plus y? Again here the distribution of x plus y is binomial with parameters n1 plus n2 and p. Now proof of this property is we know that if x follows binomial distribution with parameters n1 and p, then MGF of x is moment generating function of random variable x is equal to q plus p into e raised to t bracket raised to n1. This is the moment generating function of binomial distribution with parameters n1 and p, and MGF of random variable y is moment generating function of y is equal to q plus p into e raised to t bracket raised to n2. If y follows binomial distribution with parameters n2 and p, then the MGF of random variable y is q plus p into e raised to t bracket raised to n2. Now we have to obtain the MGF of z. Z is equal to x plus y. Z is equal to x plus y. Then MGF of z is equal to expected value of e raised to z into t, which is equal to expectation of e raised to x plus y into t. So this can be written as expectation of e raised to t into x into e raised to t into y. Again this can be written as expected value of e raised to t into x into expected value of e raised to t into y. mz of t is equal to this one. Here x and y are independent, therefore we can write expectation of e raised to t into x into e raised to t into y, which is equal to expected value of e raised to t into x into expectation of e raised to t into y. Now we know that this is equal to mgf of variable x and this is the mgf of variable y. Mz of t is equal to this one, and we know that moment generating function of random variable x, which is equal to q plus p into e raised to t bracket raised to n1 into moment generating function of random variable y is equal to q plus p into e raised to t bracket raised to n2. Now which is equal to, this can be written as q plus p into e raised to t bracket raised to n1 plus n2. Mz of t is equal to, that is moment generating function of x plus y, which is equal to q plus p into e raised to t bracket raised to n1 plus n2, which is the mgf of binomial distribution with parameters n1 plus n2 and p, that is which is mgf of binomial distribution with parameters n1 plus n2 and p. Then by uniqueness property of mgf, the uniqueness property of mgf is, for the given probability distribution there is a unique mgf if exists, and for given mgf there is a unique probability distribution. Now here, using that property, we can say that the z equal to x plus y follows binomial distribution with parameters n1 plus n2 and p. Hence the proof of the additive property. Here we proved the additive property of binomial distribution for two random variables only. Now this property can be extended for n random variables. Okay, now we see one example. See example. If x follows binomial distribution with parameters n and p, then find probability distribution of y equal to n minus x. If x follows binomial distribution with parameters n and p, then what is probability distribution of y equal to n minus x? Now solution of this problem is, if x follows binomial distribution with parameters n and p, then its mgf is mx of t is equal to q plus p into e raised to t bracket raised to n. Now the mgf of y is my of t is equal to expected value of e raised to t into y, now which is equal to expectation of e raised to t into in bracket n minus x. Y is equal to n minus x, therefore it is equal to expectation of e raised to n into t into e raised to minus x into t. Then here e raised to n into t, this constant term take out of expectation sign, which is equal to e raised to n into t into expected value of e raised to x into in bracket minus t. Okay, and again this is equal to e raised to n into t into, this is the MGF of random variable x, mx of minus t, this is my of t. Okay, then we know that the MGF of random variable x is equal to q plus p into e raised to t bracket raised to n. Here is mx of minus t. Now this can be written as e raised to n into t into in bracket q plus p into e raised to minus t bracket raised to n. Okay, again this can be written as e raised to t bracket raised to n into in second bracket q plus p into e raised to minus t bracket raised to n. Now this can be written as, which is equal to q into e raised to t plus p into e raised to minus t plus t bracket raised to n. Therefore my of t is equal to p plus q into e raised to t bracket raised to n, and which is the MGF of binomial distribution with parameters n and q. Therefore, by using uniqueness property of MGF, y equal to n minus x, this follows binomial distribution with parameters n and q. Means again, if distribution of random variable y is binomial with parameters n and q. Now we see conditional probability distribution. Conditional probability distribution of x given x plus y equal to n. Okay. Now see, let x follows binomial distribution with parameters n1 and p, and y follows binomial distribution with parameters n2 and p. Here x and y are independent random variables. X and y are independent random variables. Then conditional probability distribution of x equal to small x given x plus y is equal to n, which is equal to n1c x into n2c n minus x, this whole divided by n1 plus n2c. See,